Hello everyone. So, in any design process, you come upon a problem that you did not expect and that needs to be resolved to move forward. So for example, let's say I had my current if statement. If foo, then you could just print true. Print foo. Let's see. Let's just write some notes. Currently, it's this. However, there's a problem. What is this? Right? Well, currently, it can only be a variable followed by a compound statement. So to fill out the example, it would be something like if foo print 1 print 2, let's say, right? However, what we want, and why this is a problem, is we want to be able to say let s equal foo, where you can say something where foo is a struct, and we will contain x that is an int, say, and x will equal 5, right? However, we want to say something like if, how to explain this? If foo x equals 5 dot x exactly equals 5, then we want to print 5, let's say. However, in our want state, notice that there's an ambiguity here, right? This could either be still what we have today, a compound statement, but it could also be a type name followed by the opening curly to a struct construction. So there's an ambiguity with want. So our solution is oddly simple. It's to require the then in all cases. So we would say something like this. Now, this would effectively replace the parentheses around the if, which I know that many languages have done parentheses around the if, around the condition of the if, but I don't prefer that if I don't prefer the parentheses. Also, using English words feels a bit better, and I don't feel that this is too much of a syntactic variation because if you look at Bash, we also have a language that has the word then, and it's a different case with Bash, but it looks at the end of the day the same. So now that we've gone through our reasoning, let's go and open up. Let me just set up for building. Let me just open up the tests. We want the parser tests. Okay. So we want to find if space. Let's parse if expressions. There we already have the then. And as you notice here, another reason I picked the word then is because we already have it reserved for if expressions. parse if expressions. We'll put the word then here to require the test, and then we will also put the word here to require it. So statements, if expressions, fine. Okay. So now we get to run the make. Let's have that build, and then make test. As you'll notice, we have a failing test, which we know where it fails because it's the test we just changed. So let's open up the parser. We want the CPP file. So to fix the parser, let's see, parse if statement. Now, we may think that there's this condition, right? So here we need to say the then. We'll now assert that the lex of next token is lexer token type of if. Or no, it is then in this case. Where's the then? Well, let me just type it out then. Then. Let's just rebuild everything. Subprocess aborted. Let me just do this manually and see what happens. Subprocess aborted. Ninja. So I know that the internals here are C-tests, so why is this happening? Aborted on line 413. So we need the, no, we don't want that. We want the test parser, line 413. Ah, there's why we never detected it, because this parenthesis thing. Now, I could say that there must be a parenthesis here, but I feel that that also is ambiguous. In fact, let me just show an example for that. Right. So the test case will slightly change, but let's just show an example for that. So so if I see this, why is this, why can it not be this or this? Well, there's a very interesting there's an interesting consideration here. Consider, what if I had if open parenthesis x plus 5 close parenthesis exactly equals 10 then. So here the starting parenthesis does not mean the end of the condition, because if I allowed either or, then it would have to see the closing parenthesis, realize that it's not the end of the condition expression, and move on. This I was originally having some I couldn't even see this, and that's why I ended up working with the with Bison to prove this. Let's see. So if I do, my apologies. So for example, if I do Ninja Bison, and then if I open up the Bison, if I open up the parser, quote, you can see that, let's say I were to go over here, right? and I were to permit in the if head there to be a L paren with an expr followed by an R paren, just as a test, right? We now have ambiguities. And if I were to ask Bison for some counterexamples on this, and you see it conflicts with the unary operations, not just with that. So what it's arguing here is that this negation could either be interpreted as the end of the expression, as the end of an expression. It's arguing here that these parentheses are the end of the condition, but it's also arguing that that there could be this minus as a subtraction of the expression. So it's still ambiguous, which is right as you see here, which is why it's not too, which is why we have to switch entirely over to the then style. So let's restore. I don't want to discard that. I do want to discard that. Let's not discard that. Not discard that. Not discard that. And then if I run Ninja again, if I say Ninja test, as you see, all of our tests pass. So let's write a commit. Commit mandate then after if mandate then after if condition. This disambiguates the if okay. This disambiguates the if condition from the this disambiguates the if condition from the if body. This is needed cases such as if foo curly, as when structs are added, when structs will be added, the foo could either be a variable, and thus the condition, could either be, let's list this off, let's have a 1, a variable full, and thus the condition, come up for 2, a type name, that's the condition, with the left curly being the start of a compound statement, or a type name with the curly being the start of a struct initialization. Okay, so while we're now at it, there may also be something in the parser that will interest us. So now that we've done this, you may notice parse if statement, right? You'll now notice that the if expression is also similar. It takes a if, a condition, and a then. So if we find the parse if expression, we'll notice that at this point it's the same logic. It's parse the expression, parse the if. The only difference here is that it's conditional. We can rewrite the logic to be we can rewrite some of the logic here without the consume if. So we could effectively decrease the we could try and extract common code. I don't think that would be advisable here, but there is an option to extract common code. However, there is a second issue with our current idea for structs. That is, if I am to demonstrate it again, let x equal foo. This is perfectly valid because foo here is some other variable that we're taking x in on. However, what if you have a curly like this, right? And then there's some, and we just have some internal context, right? What this is saying is that currently this is some declaration of a variable x to be whatever foo is, and then we copy it, and then we start a compound statement. The problem is that if we want to have structs, let's do this, we'll need to have let y equals type name open curly, then init initialization, followed immediately by close curly, which here it's ambiguous because we only look ahead one token ever. And even if you look at two tokens, an initialization will look much more different. May look similar. Depends on how you implement it, but it may look similar. So, to fix that, what I'm thinking of doing is saying that let has to have a semicolon at the end. This disambiguates it. It also means that the only case where we have optional semicolon is a function call. But I think that's fine. We can always require semicolons later. So, continuing. So now let's do that for if statements. So we can grab the test for the parser, and we will now find let. We'll parse the let statement. Oh, we already have a semicolon on that. Not bad. Okay. We'll parse the let statement without semicolons and with types. And then we'll just say that it can only parse them with types. So, parse dereferences. Here we need to say that the let needs a semicolon at the end. The only problem is I can't trust that the let will always take a semicolon, which is interesting, that the let is not required to take a semicolon. Let's see if make does anything wrong. Well, that is expected. And then if I were to grab, say, make test, it all passes. But let's see if we can change something in the parser. So source parser. So let's parse let statement. Consume if semicolon. I think it would be better just to consume the semicolon. So we go here. We then say that if has an equal sign, we parse an expression. We make the let, we set the location of the let. And then we will also assert here that we will now get the next token. And it will exactly equal. I forgot to use lex. It's been some time since I looked at the code base. And we can say that this should be a lexer token type semi, right? Followed by an expression. Let's update the documentation. Followed by a there, semicolon. See that that still compiles. And that should still run through all the tests fine. So that should be perfectly fine. Then we can just commit everything. Yep. Let statements require semicolons. A between a let of a struct, let x equal type name initialization and a let followed by a compound statement. Let x equal ooh, and as you can see, right? And that should be, I hope that's reason enough for my future self. We can just push. And thank you for sitting through this short parsing update.